Hey folks, welcome back to Pre-Calc. So today we're going to be talking about inverses of a function. Some of them will be inverse functions, some won't be. Some might just be inverse relations. We're going to take a look at some notation with it, we're going to take a look at how to do it with reflections, and we're going to take a look at some special properties of them in something called the horizontal line test. Without any further ado, let's take a look. Let's go over some notation first. So if we start with the function f of x, we write the inverse of it as, it's a bit difficult to see, but this is f with a little exponent of -1 of x. Same thing if we had g of x, the inverse would be g with a little exponent of -1 of x. This doesn't mean we apply a negative exponent. We know that if I had, for instance, 8 to the negative first power, that equal 1 over 8. That's not what's happening here. It's just notation. And we read it out loud and pronounce it as f inverse of x. So this would be f inverse of x. This would be g inverse of x. If you had an h, it'd be h inverse of x. Now, finding the inverse. This is going to be how we do it algebraically. And we're just going to change x to y and y to x, and then solve. You might be saying, but Mr. Gallagher, there aren't any y's. Well, yeah. So y equals x squared. We're going to flip it so I have x equals y squared. And then just use some inverse operations. Square root, y equals plus or minus square root of x. Don't forget that plus or minus. Let's do the same thing over here. Well, y equals x to the third. You might be saying this is a very, very, very similar thing. You would definitely be right. Flip them. And then here we just take the cube root. Take the cube root, and then we're going to have x cube rooted. That's going to be our inverse. Now, we can even do this with a linear. With a linear, it's even nicer. Let's say y is equal to 2x plus 7. Well, I flip it, so x is equal to 2y plus 7. And I just do x minus 7 equals 2y. X minus 7 over 2 equals y, and that would be my inverse. It's very important to note, though, that the inverse of a function, the inverse relation, is not necessarily a function. One of these three is not a function. So the inverse relation of a function is actually a reflection. Over this line, y equals x. And that line is, you have a quick little sketch here. Y equals x is this line right here. It has a slope of 1 and a y-intercept of 0. Now, let's take a look at what these look like using our graphing calculator. I'm going to use GeoGebra Online instead of Desmos to show you a different way just because, hey, why not? We'll do this first one first. So, our original is graphed here in red. This green dotted line is y equals x. Now, if I plot the positive square root and the negative square root, I have the reflection over this dashed line. Now note, this fails the vertical line test. So in our first example, the inverse is not a function. We cannot use it as a function. But let's take a look at some other examples. So our second one, x to the third, let's see what that looks like. I have x to the third power here. Then I have its inverse right here. The inverse is a function. It's a bit easier if I get rid of the first one, because at no point here will it fail the vertical line test. You might think it gets very close here, but it's not straight up and down. And we can do the same thing with our linear function. Here we go. That's the inverse. So if we're looking at this, we see that our inverse is also a function. You'll also notice that there are reflections over this line. These two are reflections. These two are reflections. And these two are reflections. Now, here's why we use functions. For a function f of x and its inverse f inverse of x, the two cancel each other out. So whatever you plug in, you get back. So here, considering we have the function and its inverse, they'll cancel out no matter what they are, and whatever is inside the parentheses here, it happens to be a 7, we get a 7 out. Same deal down here. F inverse and F are both applying to each other. It doesn't matter which order they apply, they're inverses. So whatever we plug in here, it's a negative 10. Gets spit back out, it's a negative 10. Any number could be here, and it would get spit out here. Now, there's a nice, easy way to see if a function is invertible. You know from your textbook, that means that its inverse is also a function. So, it's if the original function is called a one-to-one function. It means that every x goes to a unique y, no y's repeat. And we can do this using the horizontal line test. Now you remember the vertical line test, we just went over it a tiny bit. The vertical line test says if something is a function. The horizontal line test says if its inverse is a function. And let's take a look here. I just pass a vertical line through. That vertical line touches twice, here and here. So this inverse is not a function. Let's do this here. I have a vertical line. No matter where I pass it, it's not going to hit it twice. You might think, wait a second, Mr. Gallagher, it's going to hit twice here. It won't hit twice there, it just looks really, really close. So that means the inverse is a function. And the same thing here with our linear. No matter where I put this horizontal line, it's only going to cross the linear once. So that means the inverse is a function. So you've watched our little presentation there. Now it's time to head on over and do some delta math problems. You're going to invert linear functions. Those are always going to give an inverse. Then you're going to do multi-step inverse functions. Both of those you can check using Desmos or any other graphing software before you hit submit, so you know you're right. It would be a really, really, really helpful thing. That way you know you're right and you're good to go. Also, you can always come back and ask me a question in the Zoom call. You can share your screen and I will help you with any individual question you got. After that, do the Q questions in problem set 1.5. The Q question should only take you 5 minutes. If you find yourself taking more than 5 minutes, stop. I'm serious. You should not be spending more than 5 minutes on the Q questions. Set a timer on your phone, and as soon as that 5-minute timer goes off, stop with the Q questions. After that, you're going to do number 23, parts A, B, and C. Number 26, there's no parts to it. And number 28, no parts to that one as well. So kind of light. After that, lesson summaries in the form below, looking for a good-sized answer. And last but not least, read 1 through 6 in the textbook and complete the reading summary. All the delta math I expect should be able to be finished by this class. So, in order to give you time for it, the video ends right about now.